This is the University of Washington's Math 120 pre-calculus course. We're looking at the fourth question from the winter 2016 final exam. This is another classic Collingwood question. We have two people who are running around a circular track. In this case, the two people are Godzilla and King Kong, and the circular track is actually around the entire Earth. Godzilla and King Kong are running up the prime meridian and down the anti-meridian is what's been given. And we know a little bit about Godzilla and King Kong's motion. In particular, we know that Godzilla starts at the North Pole, and Godzilla runs a lap in 5 hours, a lap around this circle. The circle here has radius 4,000 miles. And we know that King Kong runs 6,000 miles per hour. We don't know exactly where King Kong starts. We're given that King Kong starts with some angle phi above the equator. And we know King Kong's speed and that King Kong passes Godzilla after 3 hours. The question asks us to do three things. Part A asks us to find Godzilla's speed in miles per hour. Part B asks us to find this angle phi. And part C asks us, after 14 hours, to compute whether King Kong or Godzilla will be farther north. So if you haven't already, go ahead and pause the video and see how you do on these questions on your own. Okay, so let's take a look at part A. Part A just asks us Godzilla's speed in miles per hour. So we know that in 5 hours, Godzilla completes an entire lap. We also know that an entire lap is an entire circumference, the circumference being based on this radius of 4,000 miles. So what we have is that in 5 hours, how far does Godzilla travel? Well, Godzilla travels 8,000 pi miles in 5 hours. So the speed is simply the ratio of the distance traveled over the amount of time it took to travel that distance. So we have a solution for part A. Godzilla's speed is 8,000 pi over 5 miles per hour. So how about part B? We want to know this angle phi. We need some way to relate the fact that King Kong passes Godzilla after 3 hours. In particular, let's express Godzilla's position as a function of time and King Kong's position as a function of time. And in particular, let's express their position simply by saying their radian measure. So in other words, if King Kong were right here, we'd say his position was 0. Godzilla's initial position is pi over 2. When Godzilla gets to here, his position is pi. So what can I say about each of their angular speeds? Godzilla runs 2 pi radians in 5 hours. So Godzilla's angular speed is 2 pi over 5 radians per hour. King Kong runs 6,000 miles per hour. Circumference here is 8,000 pi. Well, let me just kind of multiply by the conversion factor here. I'll start with the angular speed, or sorry, the just linear speed of King Kong is 6,000 miles per hour. And now what I want to do here is get rid of these miles and replace them with a radian measure. And what I have here is that 8,000 pi miles. Sorry for the poor space management here. This is a denominator of 8,000 pi miles. My conversion factor is that 2 pi radians is the same as 8,000 pi miles. So I can say that King Kong's angular speed then is is 1.5 radians per hour. So now I have their angular speeds. I also have their initial positions in some sense or another. So I can express their positions as functions of time at this point. I'll use, well, let me use little g to represent Godzilla's position as a function of time. Godzilla starts at pi over 2, and then each hour, Godzilla travels 2 pi over 5 radians. And I'll use little k to represent King Kong's position as a function of t. Now I simply want to know what t value will make these agree. So I've modeled Godzilla's position as a function of time and King Kong's position as a function of time, and I know that their positions are coinciding at t equals 3. So this is the phi that is the angle where King Kong starts at. And now the final bit of this question asks us to compare King Kong and Godzilla's position at after 14 hours have passed. In other words, at t equals 14, we can simply plug in 14 to both of these and see what we get. Plugging in 14 to this. So now I have the position of Godzilla and of King Kong. I simply need to find out which of these positions is farther north. So 6.1 pi. 6 pi would be here. So at t equals 14, Godzilla is just past, meaning just above the equator, 0.1 pi above the equator. And meanwhile, k of 14 so k of 14 is 21.84. This is the position in radians of King Kong at t equals 14. Not immediately clear where that lies on the unit circle. I'd like to know how many full rotations this is. Let me take that number and divide it by 2 pi. This suggests 3.475 rotations. This is actually going to be quite close. King Kong's position, 3.475 rotations. I actually have to pay a little bit more attention than I expected to specifically what these numbers were. So what I have is that King Kong is about 0.025 of a revolution before the equator. In other words, above the equator is 0.025 of one revolution. In other words, 2.5% of one revolution before the equator. 2.5%. And that other Godzilla was 0.1 pi, 0.05 of a revolution. In other words, 5% of a revolution above. So we find that although it is quite close, Godzilla is slightly higher than, or slightly farther north than King Kong. Let me see if I can write this in a way that makes it a little bit clearer.